Hello guys, so today we are solving this problem, flip equivalent binary trees. So for a binary tree or T, we can define a flip operation as follow. Choose any node and swap the left and right child subtree. So that is called a flip operation. For example, here you can say 1 is the parent. So it be flip 2 and 3, it will become 3 and 2. So this is called the flip operation. Okay, so a binary tree X is flip equivalent to a binary tree Y if and only if we can make Xn equal to Y after some number of flip operations. For example, we can take one example here. So for example, we have, let's say, two trees T1 and T2. Okay, so see here, if we look at the root node of it, this is root, right, and this is the root of it. So this is 4 and this also 4, so not a problem, both of them are equal. Now come here to the left child and right child. So left is also same, this guy is 3, the root's left child is 3, here also 3, this right child is 5, this is also 5, so not a problem. So far everything is going in an equivalent way. Now we are coming to this guy. Okay, we'll look for the childs of this and this. Okay, so this has left child equal to 10 and right child equal to 20, but this guy has right child equal to 20 and left child equal to 20 and right child equal to 10. So now what will happen if we do a flip here? If we make right child equal to left and left child equal to right, then this would become a flip operation. And after doing this flip operation, both of them, T1 and T2, are equivalent. So what we have to do is basically, let's read the question. So given the root of two binary tree, root 1 and root 2, return true if the two trees are flip equivalent, means if we can do some flip operation, they should become the equal, right? This is what we have to do. Same we are doing here. So they are equivalent, but we can make them equal if we do a one flip operation here, right? That means they are flip equivalent. So this is what we have to do. Now what would be our approach here is, so what we can do, so till the time everything is going fine, we are good, right? See here, we were good here, this is 4, this also 4, 3 5 3 5, but whenever this came 10, this came 20, so basically if their left and right child are appearing in the reverse order, then also it is fine. But if there is any mismatch completely at any place, then we have to immediately return false. For example, this is 5, had this was 15, in that case when we will come to this node is completely different, so even a flip operation cannot save us. So in such scenarios we can directly say that this would not be the equivalent, right? So this is what we have to do. Okay, so now what would be our approach? The approach is we will use a stack approach. So what we will do is basically we will create an stack. Suppose this is our stack. Okay, and in this stack what we will push basically the pair of the nodes, right? So we will start from here, let's say. So 4 and 4, both our nodes are 4 and 4, both are equal, so not a problem. So we will push them into stack. Okay, now initially we push them into stack. Now we'll pop out this guy, because after pushing these two top guy we have stack. So while stack is not empty, we will pop this out. Okay, so let me pop it out. So when we will pop it out, we will check for the left and right child of it. Okay, we popped them into it when they were equal. Okay, so we will pop this out, 4 and 4. So what are the left and right child here? So we'll look for the left and right child. So left child is, so left of this guy, which is 4, right, its left child is 3, and the other guy is left child is also 3. That means they are same. If they are same, we have to check it further deeper, that hey, is there any violation of the rule? So we will go for this 10 and this 20, right? So we would have new pair 10 and 20. So we will push this pair as well. So 10 and 20 is the another pair we would be pushing here. Okay, but yeah, before going to this, I am starting from here. So what we will do is we will push these guys. So 3 and 3 would be pushed, because this is left child and right child, left child and left child of both this guy, root node. So left child is 3, here also this node. So we have pushed this. Basically these are not the value but the nodes, so you can consider them as the node. So we have pushed this 3 and 3, and also this right child is 5 and right child is 5. We will check. So we will push also the 5 and 5, right? So we have pushed them. Now what we will do is, after doing this operation, we will again check for it. We will pop them out, right? So we will pop them out. So first of all, we will pop out the 5 and 5, right? So we are popping out 5 and 5. So 5 and 5, this 5, left child and right child, both are null. For this guy also, left child and right child, both are null. So not a problem. We wouldn't push any more thing here. We are done for here. Now we have 3 and 3. So we will pop out 3 and 3 as well. Okay. So let's pop out 3 and 3. So hey bro, 3 and 3, you are also coming out of it. So 3 and 3. Okay. So what is this 3 is producing? Left child is 10, its left child is 10, and its left child is 20, and its right child is 20, and its right child is 10. That means they are in flip prone operation. Okay, so flip can happen. So in case of flip condition is matching, then what we will do? In this case, we will push this pair. The first child, I mean the left child of first one and right child of second one. Okay, so we will push 10 and 10 here. Okay, we will put 10 and 10 here. Okay, now we'll go to the right child of them. Okay, left is done. Now look for the right. So this guy is right is 20 and its left is 20, right? Because this is a flip operation. So we will take the right of it, which is 20. We will take the left of it, which is also 20. Okay, now we are done with this. Now what we will do? We will pop them out. So far everything is, condition is matching. We will take a different example as well. So let's pop them out. So 20, right? Means this guy and this guy we are popping out. 20 and 20. So what is the left and right? Both are null, right? Both are null. This also null. So means we have popped this out already. Now we'll go to 10 and 10. Okay. So let me pop this out as well. So what is the left and right of 10 and 10? So go to this 10. What is the left and right? Left and right both are null. Okay. So we are done. And left and right both are null. Similarly, left and right both are null for this as well. Okay. Left and right null. So we are done. And finally, what is happening? We are coming out of the stack, right? That means nowhere condition was broken. If condition was not broken, that means we have to return true, because we were nowhere found any violation. So this was a happy path. We will take a different example. We will modify this tree itself. So I'm going to modify it. Let's say instead of 5, we can take some different value. Okay. So if we take a different value, what will happen? Whenever we will find a different value, we will immediately break everything and return false. So for example, this is 15, let's say. Okay, so what happens? Initially we will push 4 and 4, right? So 4 and 4, it's fine. We'll pop this out. When we will pop this out, this will come out of it, and we will look for the left child of 4 and 4, right? So its left child would be 3, its left child would be 3. Okay, so 3 and 3 is fine, correct? 3 is fine, but when we will go to the right child of it, so its right child is 5 and its right child is 15. So whenever there is a mismatch, so this is a direct mismatch, value mismatch. So what we will do? We will return immediately false. Return false. We don't have to go anywhere to any stack, any operation. Everything is stopped. So whenever a condition is broken, we have to immediately return false. Otherwise, we will keep on going. So when we will keep on going? When the values are same, or values are same in this way, that left equal to right and right equal to left, like this. So if the values are same, or left equal to right, right equal to left, then only we will proceed. If nowhere this condition is matching, we have to return immediately false. This is what we have to do. So let me show you my corresponding code for it. So this is my code. Let me show you. Here I have written one utility method, r equal. This is just checking whether the values are same or not. So two nodes, n1 and n2. If both of them are equal, that means they are equal. That means true. If either of them, none of them is null, and values are same, then it is returning true. Otherwise we are returning false. This is very simple, just checking for the values. Okay, then what we are doing, I have created one stack of the array of tree nodes. Array of tree nodes means we need two values, right? Just a pair. So we are pushing the root of both of them initially. okay, as a array. So after adding this, what I am doing is, while this is not empty, the stack is not empty, what we are doing, we are popping out the element, okay, and these are the our nodes at 0 and 1, right, because it's two size 3 node array. So we would have an n1 and n2. So we are checking here that if n1 and n2 both are null, that means we will continue. Okay, continue. Why? Because see here, you can see it here. See here, like 5, right? This is null, and if value was 5, so 5 and 5, after going to left and right, they will produce null. That means we have to check for other values. If this something is stopped here, that doesn't mean we have to stop. We have the further array as well, further tree as well. So we have to check there. Okay, so yeah, so we are checking over here. Now, if one of them are null, okay, so if this is null, then we are continuing. If any one of them is null, then we are returning false, because one of them would not be null corresponding. That means that is a violation of equality. So we are returning false. So see here, we are also looking for the values. If n1 dot value is not equal to n2 dot value, like here we did see here, this was 5, this was 5, and this was 15. So whenever we came to this node, the values itself were not same, so we immediately return false, right? So that is the point what I am returning here. If values are not same, return false. Then see here what we are checking. If none of them, these conditions are there, then what we are doing, we are looking for the left child, n1 dot left and n2 dot left, and the right child of them. Okay, so when left child and right child both are equal here, we are using this r equal method, right? Left of this, right? See here, let me show you here. Left of this guy 4 and left of this guy are same. Left of right also same initially when it was 5 value, right? So that is the case. If that is the case, then what we are doing, we are pushing the left of both child and right of both the nodes. Okay, otherwise if this is not the case, then we have to look for the flip condition, whether hey, left right and the right left of both nodes are equal. If they are equal, then also we can have a flip operation, right? So we can push them for further check in the deeper side. So see here, I am checking, I am pushing the n1 dot left and n2 dot right, and the n1 dot right and n2 dot left, because we found a flip condition. So either they are completely equal at every location, or they are equal at the flip operations. Then what we will do, we will push them. Otherwise we have to return false. For any other case, we don't have to proceed. So that is why if none of them condition is matching, we will go to else false. So through this while loop, if nowhere we are able to return anywhere, that means we are coming out of loop. And if we are coming out of loop, no condition was mismatched, so we have to return true here. So this is what I am doing. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.